Hello everyone, this is day 11 of our data science series. Today, in this video, we are learning about the dimension reduction technique in Python. Dimension reduction is a technique used to reduce the number of variables, features in a data set while preserving as much information as possible. It is particularly useful when dealing with high dimensional data, and it helps to improve the efficiency of models, reduce multicollinearity, and prevent overfitting. First is identifying multicollinearity in Python. Multicollinearity is a situation where two or more predictor variables in a regression model are highly correlated. This can cause problems in model interpretation, making it difficult to access the individual effect of each predictor on the dependent variable. Here's how you can detect multicollinearity. Steps First step is correlation matrix. Check the correlation between pair of variables and variance inflation factor VIF. Compute VIF to quantify how much a predictor is influencing in the variance of regression model due to its correlation with other predictors. So here in this code we import a NumPy package, pandas, stats models, scalar dataset, and Seaborn library, matplot library. In step 1, we load the Boston housing dataset. Data equal to load Boston, and in step 2 correlation matrix, and step 3 variance inflation factor, add a constant to independent variable for VIF calculation. Calculate VIF for each features, and with the help of print statement we print VIF data. Next is applying principal component analysis PCA. Using Python principal component analysis PCA is a popular technique for dimensionality reduction. It transforms the features into a new set of variables called principal components PCS, which are linear combinations of the original variables. The principal components are ordered such that the first few components capture most of the variance in data. In this code, we import necessary libraries from scalar decomposition, import PCA, and scalar preprocessing, import standard scalar. From scalar datasets, import load Boston. Step 1, load the Boston housing dataset. In step 2, standardize the data. In step 3, we apply PCA method. In step 4, we explain variance. In step 5, we plot the explained variance to decide how many components to retain. In next step, commutative explain variance, and optional if you want to reduce the dataset to, for example, 2 components. Here in last, we check the reduced data. Now, correlation. What's the correlation matrix? A heat map is generated to visualize the pairwise correlation between the features. High correlation above 0.8 or 0.9 between two variables can indicate multicollinearity. Variance inflation factor. The IF, the VIF quantifies the inflation of variance caused by multidisciplinary and a VIF have value above 10 typical suggest high multicollinearity. Steps to apply PCA. Standardize the data. PCA is affected by the scale of variables, so it is important to standardize the data before applying PCA. Fit PCA. Apply PCA to reduce the dimensionality. Examine explained variance. Check how much variance each principal component explains to understand how many components to retain. Here it is the summary of our overall topic. Identifying multicollinearity. We identified multicollinearity using correlation matrix and variance inflation factors. A high correlation between features or a high high VIF suggest multicollinearity, which can lead to instability in regression models. And principal components analysis, which is also called PCA. We applied PCA to reduce the dimensionality of a dataset while retaining the maximum variance. PCA helps mitigate the issue caused by multicollinearity and overfitting by transforming the features into uncorrelated components. Both techniques, multicollinearity detection and PCA, are crucial for improving model performance and ensuring the validity of statistical models. So this was all about the our dimension reduction techniques, how we can use in data science. So thank you everyone.